Hello everyone, welcome to Math World. This video is to discuss Cambridge International AS and A-Level Mathematics Paper 5, which is a Probability and Statistics 1 for May-June 2020, and the code is 9709/53. So let's move on to question number 1. So for question number 1, Jen goes to college each day by any one of cars or bus or walking. So there are three methods to go to the college. Now, the probability that he goes by car is 0.2, and the probability that he goes by bus is 0.45, and the probability that he walks is 0.35. When John goes by car, the probability that he arrives early is 0.6, whereby when he goes by bus, the probability that he arrives early is 0.1. And when he walks, he always arrives early. Now A, draw a fully labeled tree diagram to represent this information. Okay, so basically there are three ways to go to the college. The first is car, the second is bus, and then the third is walking. Okay, so car is with probability of 0.2, then bus is 0.45, and walking is 0.35. So the total of these three probabilities will be 1 here. Okay, then he arrives early. So this one is early. Okay, this one is not early. Same goes to the other two methods. Now, when he goes by bus or by car for the first branch, he arrives early with probability of 0.6. So here 0.6. Not early means 0.4. When by bus, early is 0.1. Okay, the other one is 0.9. So the total probability is 1. And when he walks, he always arrives early. So here I need to erase. Always arrive early means 1. The probability is 1. Okay, or probably if you just show not early, then just label it as 0 probability. So this is the tree diagram. Now part B, find the probability that Juan goes to college by car, given that he arrives early. Given that is conditional probability. That means now probability goes by car, given that arrives early. Okay, so for the conditional probability formula, PA/B, this is PA intersects B over PB. That means now your A is car, B is early, arrives early. That means this is going to be P by car and arrives early over P arrives early. Okay, so car and early means that it will be just a multiplication of these two probabilities. So 0.2 times 0.6. Now, for the probability of arriving early, it can be by car, okay, by car, or by bus, or by walking. So it means that I need to calculate the total of these three probabilities. So firstly, I will just write 0.2 times 0.6. All is plus. Okay, the by bus and early 0.45 times 0.1. Or by walking 0.35 times 1. Then from here, you will be getting 0.12 over 0.515. So at last, the answer is 0.233. So this is the probability of B. Now for question number 2, In a certain large college, 22% of students own a car. 3 students from the college are chosen as random. Find the probability that all 3 students own a car. Okay, so for this is basically probability equals to each student each student own a car is 0.22, 22%. This is for first student. Okay, this means now here 3 students, all 3 own a car, means these are the 3 independent students. So you basically just multiply 0.22 for 3 times, or I would say that it is power 3 of 0.22. Then you will be getting 0.016106. So that is the probability that correct to 3 significant figures. Okay, next. Part B, 16 students from the college are chosen as random. Find the probability that number of these students who own a car is at least 2 and at most 4. Alright, so basically this is the binomial distribution question. So your X is the number of students who own a car. So B is binomial distributed. Now, since you are considering 16 students, the probability of owning a car is 0.22. Okay, then from here I will say P is 0.22. That means the Q is 1 minus 0.22. That is going to be 0.78. Now, you need to calculate Px at least 2. At least 2 means 2 onwards. So it will be greater equals to 2, at least 2. At most 4. At most is maximum. Okay, at least is minimum. So maximum 4. So less equals to 4. Then I will just say this is basically x equals to 2 until 4. And you need to count the 3 probabilities. So for your information, binomial distribution x is b and p. The probability is ncx, px, qn minus x. Okay, this is the binomial distribution probability. Then this is going to be 16c2 0.22 squared because 2 successors. Then you will have the rest of values 14 plus 16c3 0.22 cube, then 0.78 power 13 plus 16c4 0.22 degree 4 and then 0.78 degree 12. Okay, then from here I will get 0.179205. Here as the working I will give more decimal places. The next value 0.135877. Then the third value is going to be 0.216221. Okay, so when I add up these 3 values, that is going to be 0.6313. And now I round up to 3 significant figures by looking at the 4th significant figure, that is 3. So that is going to be 0.631. Okay, that is your final answer. Now for next question number 3. In a certain town, the time X hours for which people watch television in a week has a normal distribution with mean 15.8 hours and standard deviation 4.2 hours. Now A, find the probability that a randomly chosen person from this town watches television for less than 21 hours. So now your X is the time. Okay, so X is normally distributed with mean 15.8. Standard deviation is 4.2. So we always write variance because our general formula is X is n mu sigma squared. So the sigma squared is a variance. And now you need to calculate probability is P that the time spent on watching television is less than 21 hours. So X is less than 21. So to get this probability, firstly we need to standardize it. Therefore, you have to standardize using x minus mu over sigma formula. So then from here, I will be getting P Z less than 21 minus 15.8 over 4.2, because the sigma is basically the standard deviation, and now I am writing 4.2 squared, that is the variance. Okay, so from here, when you calculate the value, that is going to be 1.283. Okay, and now here you just sketch a graph. Once you have standardized it, it is symmetrical at the 0, and now mark the line for 1.238, and this is less than. So less than means the region towards the left side. So this region is given in the table. That means you can just direct read the probability from the table. That is going to be 0.8922. Okay, and round up to 3 significant figures, that is 0.892. So done for the first part, A. Okay, now let's move on to the next question. Find the value of k for which px less than k is 0.75. So now again, use back the same distribution. Okay, so first of all, I will standardize it. So whenever you standardize it over z less than, the x tends to z, then k minus mean. The mean in this question remains the same, 15.8, then standard deviation 4.2. That is 0.75. Okay, so now I need to sketch the graph to identify where is this line. Okay, where is this line? Alright, so now here it is always symmetrical at the origin. Now look at here, we have two choices, either on the right, k minus 15.8 over 4.2, okay, or on the left. So we are not sure which one is the correct line. So what you need to do here is to check this value. Check this inequality. This is less than. Less than means the region is towards left side. So when towards left side, okay, so for the green region, then the probability is 0.75. Okay, or probably is the orange region. This is 0.75. Now for information, the graph is symmetrical at 0. That means the PZ less than 0, it should be 0.5. Okay, because it's half of the whole graph. So obviously, the green color is not logic because it is a smaller region compared to the 0.5. But then the probability is higher. So which means basically your region is the orange region. So I have to erase the green color. So this is how we check if you are not sure where is the line. Okay, so then from here, now when you refer to the graph, obviously the orange line is on the right side, so it's already positive, and then the region is towards left side. So this 0.75 is basically available in the table. So I will just write from table. Okay, then I can direct read the value of the z from table to get 0.75 probability, and now you will be getting 0.674. So once you have these two steps, you just compare. Basically, the highlighted one will be the same value. Okay, then I will just write k minus 15.8 over 4.2, that is 0.674. And then now to get the k, this 4.2 will be moved up, okay, followed by moving the negative 15.8 to the right side. So basically, I'm getting k equals to 4.2 times 0.674, then plus 15.8. And then here you will be getting 18.6. So that's the solution for k. Okay, now question number 4. A fair four-sided spinner has edges numbered 1, 2, 2, 3, and a fair three-sided spinner has edges labeled -2, -1, and 1. Each spinner is spun and the number of edges on which it comes to rest is noted. the variable x is a sum of the two numbers that have been noted. A. Draw up the probability distribution table for x. Okay, for this case, I will be drawing a table. So the column will be showing these four results. Okay, the first four-sided spinner. So it will be 1, 2, 2, and 3. Then for the row, it will be showing the three-sided spinner and labeled -2, -1, and 1. Okay, now, given the x is a sum of the two numbers, so now I will get the total. So 1 plus -2 is -1. Okay, 1 plus -1, 0. 1 plus 1, I get 2. Now, 2 plus -2, it will be 0. Then 2 plus -1 is 1. 2 plus 1 is 3. So for the next one, it will be the same result. Just copy. Now, for the last column, 3 plus -2 is 1. 3 plus -1 is 2. 3 plus 1 is 4. So the orange color is basically the x values. Okay, that means now my probability distribution of x, that is a table which consists of the orange color values. So my x values and then the probabilities. So obviously my x will be -1 and then 0, 1, 2, 3, 4. Okay, so when -1, it is 1 out of 12 results. So the probability is 1 over 12. So when 0 is just count, obviously there are 3 zeros. Therefore 3 over 12. So when it is 1, I get 3. So 3 over 12. When it is 2, I have 2. These are the two outcomes. Okay, when it is 3, there are 2 over 12. And when it is 4, I get 1 over 12. So this is the probability distribution table of x. Now B, find variance x. So before we get the variance x, we need to calculate the EX. So now EX is basically summation x times P. So this is the expected x. So which means you need to multiply the x with the P first before you sum. So you multiply all this, then you plus all together. That is our EX. So I'll get -1 times 1 over 12 plus 0 times 3 over 12 plus 1 times 3 over 12 plus 2 times 2 over 12 plus 3 times 2 over 12 and lastly 4 times 1 over 12. Okay, so we know that the denominators will be always 12. So you just calculate the numerators. So it will be 16 over 12. And this can be simplified into 4 over 3. That is our expected value. But then since we need to calculate the variance x, now we need to calculate EX squared. So basically EX squared is summation x squared times P. So it means that now all the values before the bracket, all this you need to square it because all these are the x. Right? So which means I will be getting -1 squared times 1 over 12 plus 0 squared times 3 over 12 plus 1 squared times 3 over 12 plus 2 squared times 2 over 12, then 3 squared times 2 over 12, and lastly 4 squared times 1 over 12. Then from here, you will be getting 46 over 12. That is going to be 23 over 6. And now my variance x is basically EX squared minus square of the EX. So EX squared is 23 over 6. So you square the mean. Mean is 4 over 3. And here you will be getting 37 over 18. So that is the variance. So for question number 5, a pair of fair coins is thrown repeatedly until a pair of tails is obtained. The variable x denotes the number of throws required to obtain a pair of tails. Okay, so you have to repeat this experiment until you get a pair of tails. That means this is basically geometric distribution. Okay, so now find the expected value of x. So for information, if let's say the x is geometric distributed with p, the mean is basically 1 over p. Okay, expected value is a mean. So from here, right, I will say to get, now you see the coin, right, a pair of coins. So to get a pair of tails, right, so here you will just write the outcomes as equals to, when you toss a fair coin, it will be H H, T T, T H, H T. Okay, to get a pair of tails means the P T T. This is basically 1 over 2 times 1 over 2 because it's fair coin. Alright, so it will be 1 over 4. This is our P. P is 1 over 4. So since your x is geometrical distributed, so you can just write 1 over 4. That means your EX is 1 over P, which is 1 over 1 quarter. So I get 4. So that's the solution for this question. Now part B, find the probability that exactly 3 throws are required to obtain a pair of tails. So if 3 throws means that you will be getting, okay, 3 throws are required to obtain a pair of tails means that you are getting first 2 are not T. This is because you are throwing 2 fair coins at the same time, right? A pair of fair coins. Then the second time when you throw, it's also not getting a pair of tails. Then the third time, you are getting a pair of tails. So this probability, okay, now from here, we know that PTT is 1 over 4 from the previous calculation, right here. So if not 2 tails, a pair of tails, that means this is 1 minus 1 over 4. That is going to be 3 over 4. So from here, I will know that the probability is basically first 2 times you are not getting the pair of tails. So the probability is 3 over 4. And it will be power 2 because you multiply it for 2 times. And then third time, it will be with probability of 1 over 4. Therefore, this is going to be 9 over 64. Okay, part C, find the probability that fewer than 6 throws are required to obtain a pair of tails. So fewer than 6 throws means x less than 6. Now for your info, when the x is geometric distributed with p, we have a formula here. Px less equals to x, that is 1 minus q to the power of x. Okay, so then from here I know that this is same as p. Less than 6 means that it will be less equals to 5. It's up to 5. So when up to 5, just apply this formula, which means now my x is 5. So it will be 1 minus. Now remember, a pair of tail, the p is 1 over 4. Okay, then the q, this is your q. So from here, I will say p is 1 over 4, my q is 3 over 4. So just apply this formula, it will be 3 over 4 to the power of 5. And then at last, you will be getting 781 over 1024. And then this is going to be 0.763. So done for the part C. Okay, on a different occasion, a pair of fair coins is thrown 80 times. Now, use an approximation to find the probability that a pair of tails is obtained more than 25 times. Okay, so now your n becomes 80. Your p is 1 over 4. So when I calculate the NP, that is 80 times 1 over 4, you are getting 20. Okay, then the NPQ, this is 20 times 3 over 4, because the NP is already 20. So that means you are getting 15. Okay, so now the suitable probability, because you are throwing 80 times, so no longer geometric distribution. Okay, so it becomes binomial. So from here I will say at first it is binomial distributed, mean the n is 80, p is 1/4. Now it has been approximated to normal, right, because of the n is large. Okay, then from here it will be mean of 20, variance of 15, because MPQ is a variance. So now remember, this binomial is discrete. Random variable, this n is normal. I mean this normal is continuous. I would say continuous. So from discrete you change to continuous, means that you need to carry out the continuity correction factor. So now it's mentioned greater than or more than 25 times. So you need to count px greater than 25. So when greater than 25, basically I will sketch 25. But because of more than 25, my x values supposedly 26 onwards. Okay, so the tick means the x values. But then now, according to the approximation, normal approximation to binomial, we need to plus minus 0.5 from this value, from the 25. That means it might be 24.5 or 25.5. Okay, so by looking at this inequality, it is more than means here is also more than. So obviously I have to choose 25.5 to include the two ticks. So which means here I will write this is same as PW more than 25.5. Though this is how we decide whether you plus or minus 0.5. Alright, and this plus or minus 0.5 only applicable to continuous, I mean to normal approximation to binomial, because of different type of data. So from here, again, when it is normally distributed with mean, mu, variance, sigma squared, we need to standardize it. So this can be done by x minus mu over sigma. So then from here, I will change the w to z, then it will be 25.5 minus the mean is 20 over square root of 15. Then with this, you have to simplify it. It will be z more than 1.2420. Now, since it is more than, you cannot get the answer from the table. What I need to do is, I will just change to less than first. This is 1.420. The region is basically towards right side. But then the table is showing you the region towards left side. So in order to use this value from the table, I will just say total probabilities minus the probability that less than 1.420. So this is going to be 1 minus PZ less than. And now get the probability from the table. That is going to be 0.9222. Okay, and you will be getting 0.0778. So this is the solution of this question. Question number 6. The annual salaries in thousands of dollars for 11 employees at each of the two companies A and B are shown below. Now A, represent the data by drawing a back-to-back stem and leaf diagram with company A on the left-hand side. Okay, so this is company A on the left side, and then company B on the right-hand side. Okay, so now check the smallest value. Okay, basically for the first row they are arranged in order. So smallest is 3, 30, biggest is 64. But then for the company B, the smallest is 26, and then the biggest value, the highest value is 52. Okay, so it means that my middle here, it should be 2 until 6. Okay, now for company A, 30, 32. So 30, 32, 35. Then 41 2 times, then 42. After that, 47, 49. 52, 53, and then 64. Okay, so now for company B, smallest is 26, then followed by 30, then 31. Then after that, you will get 35, 38, then followed by 41, 42, 42. Okay, so you must arrange 47, 49, lastly 52. So this is the back-to-back stand and leaf diagram, but then do not forget the key. Write down the key first. The key is, let's say I take this 0, 1, 3. Okay, just an example. You can take any of the values. So this means 30. Okay, now all these values are thousands in dollars. So that means this is 30,000 for company A. Okay, and then 3, 1 here means 31,000 for company B. So then this is the complete back-to-back stem and leaf diagram. Okay, now part B, find the median and interquartile range for the salaries of the employees in company A. Okay, so now median is basically half of n plus 1 theta. So now basically when you look at the question, 11 employees means that you are getting 11 data here. So the n is 11, therefore this becomes half of 11 plus 1, which is number 6. Theta number 6 is my median. Okay, because now it is the position of the median, it's not yet the actual value. So when this is 6, now remember we have arranged it in order. So this is theta number 1, 2, 3, 4, 5, 6. That means your answer is 42. 42,000. That is the median. Okay, so now to get the interquartile range, we need to get Q1 or the lower quartile. Q1 is basically half of the first half. Okay, middle of the first half. So now basically when you look at here, okay, so let me erase all this first. Now I have 4 values. Sorry, I have 5 values on the left side. These are the 5. So when I take the middle of that, it will be the third one, right? Therefore, it is 35,000 because you divide equally left and right side. So it will be 35,000. Now my Q3, which is the upper quartile, right? My upper quartile you have to arrange. So that is from the greatest value. So 1, 2, 3, 4, 5. And then again, these 5 for the yellow color. So it will be the middle. That means it will be 52,000. That is my Q3. So I will write 52,000. So now my interquartile range, that is Q3 minus Q1. Then you will get 52,000 minus 35,000. This is going to be 17,000. Okay, so done for the parts B. Okay, now a new company joins company B. A new employee joins company B. The mean salary of the 12 employees is now $38,500. Find the salary of the new employee. Okay, so now from here, instead of considering the 1,000, I will just divide by 1000 first. That means now the mean is 38.5. So we know that the mean is basically the total x over n. Right? So now I will write 38.5, my total x in the company B. So I will refer back to my company B and write down all this. Right, get the total of all these numbers. So here I will just erase, then I will copy down all this and add up. So that will be my total. And then I will let the new employee salary be X. So now when you list down the total here, it will be 26 plus 30 plus 31 plus 35. Okay, you can refer to the original data here, or you can just refer to your stem and leaf diagram. It's up to you. Alright, so I will refer to the stem and leaf diagram. Then here is going to be plus 38 plus 41 plus 42 plus 42 plus 47 plus 49 plus 52 plus X. X is a new employee's salary over 12 because there are 12 employees now. So the 12 move up, multiply with the 38.5, and then now you get the total of first until 11th data. Therefore, that is going to be 433, then plus X. Okay, so I will let X be the salary of new employee. Okay, then from here for the left hand side, that is going to be 462 equals to right side 433 plus X. Therefore now my X is 462 minus 433. So this is going to be 29. Okay, and now because the salary is in dollars, so this is in thousands, so this is in thousands. Right, that means here I will just write the new employees salary is $39,000. So that is the salary of the new employee. Okay, now next question 7a. Find the number of different arrangements of the 9 letters in the word Cilicia. Okay, so now what to do here is you have 9 letters, but I found that there are some repeating letters. So here 9. Out of these 9, I have 2 E's and then I have 2 L. Okay, and then 5 others. So others means there only appears once. Okay, so now from here to get the number of arrangements is basically using factorial. So I'm arranging 9, all 9, therefore 9 factorial. But if you just use 9 factorial, that is referring to all 9 different letters. But then when you look at this analysis, there are 2 E's, 2 L. Okay, so I have to divide by the 2 E's and 2 L's. Therefore, this is going to be 90720. So part B, find the number of different arrangements of the 9 letters in the same word in which the first letter is C, the 5th letter is T, and the last letter is E. Okay, so first is C, second, third, fourth, 5th is T, number 6, 7, 8, 9 is E. Okay, so now, since the C, T, and E are fixed, okay, just now we have 9 letters, remember? 9 letters, you have 2 E's, you have 2 L, and 5 others, which means now you already fixed 3. Okay, so remember, just now, 2 E's, so E is taken, so now left 1. Then C and T belongs to others, so here left 3. Okay, that means now you still have 1E, 2L, and 3 others. So now we just need to arrange for the remaining letters. So number of arrangements, it will be 6 factorial. Yes, correct, 6 factorial, because 1E, 2L, and 3 others, total is 6. But then out of these 6, there are 2L. So divide by 2 factorial. That means you will be getting 360 arrangements. Okay, now part C, find the probability that a randomly chosen arrangement of the 9 letters in the word does not have the 2 E's together. Okay, so if does not have the 2 E's together, I get the arrangement first. So number of arrangements, when does not have 2 E's together. Okay, that means now I will be arranging the rest first. So which means I will arrange C, skip the E, so L, then after that S, T, I, A, L. So here, out of 9, I skip the E, 2 E's, means that here there are 7, right? So I will arrange these 7 letters first. So 7 letters, but out of 7 letters, you have 2 L's. So divide by 2 factorial. And now here, to allocate the E, the 2 E's. So I have 1, 2, 3, 4, 5, 6, 7, 8. So out of 8, I need 2. But since the 2 E's are identical E's, therefore I just write 8C2. Okay, then here you will be getting 70560 ways to arrange so that the 2 E's are not together. Then now, but then the question asking for probability. So now probability, we refer to the definition. PA is NA over NS. So NS is always the arrangements without restriction. So now the NA is the one with the restriction. The restriction is the two E's are not together. Therefore, I get 70560 arrangements over the NS means arrangements without restriction. That is the answer from A. So I divide by 90720. So then this is going to be 7 over 9. Okay, now 5 letters are selected as random from the 9 letters in the same word. D. Find the number of different selections. If the 5 letters must include at least 1 E and at most 1 L. Okay, so 9 letters, you have 2 E's, 2 L's, and 5 others. Okay, now from here, you need to choose 5. Out of this 5, you have minimum 1 E. And then maximum 1 L. Okay, so now from here, means that I will say I choose 1 E, and then no L. Okay, then probably I choose 1 E and 1 L, because maximum is 1 L, so I need 3 others. Then now here, I will have probably 2 E's, then 3 others, and then probably 2 E's and 1 L, 2 others. So the underline is actually for others. Okay, so now here, I need to choose all this from others. Okay, and the question is asking for different selections. So for your information, since the E is chosen, is fixed already, we have to choose E. So no need to consider how many ways to choose the E, just one way, right? We just take one from the 2 E's. So what I need to consider here is basically just consider the underline. I need 4 underlines from the 5 others. That means my number of selection is basically 5C4. Okay, all these are all, right? It can be 1E or 1E, 1L, or 2 E's or 2 E's and 1 L. Alright, that means all is plus. Now for the second case means that you have chosen 1 E and 1 L. So means that now I need 3 others. So it will be 5C3. Or you have chosen 2 E's, then these 3 underlines are others. So it will be 5 choose 3. Or lastly, I need to choose 2 others from 5. Therefore 5C2. Okay, so when you calculate, 5C4 is 5, 5C3 is basically 10, and then 5C2 is also 10. So basically you are getting 35. So these are the number of selections that fulfills the requirements. Okay, so I have completed this paper and also comes to the end of the video. Thanks for watching. Please like the video and also subscribe to the channel, and also share this channel with your friends if you enjoy watching my videos. Okay, thank you everyone. Bye.